In this video, we will look at acceleration in uniform circular motion. It's not very intuitive और हम लोग उसको बहुत अच्छे से धीरे धीरे समझने की कोशिश करेंगे. This is a very slow video, very slow treatment. If you are in a hurry, I recommend that you don't watch this video because we'll be going through each step in detail. कुछ भी हम लोग skip नहीं करेंगे. तो पहले आपको मैं दिखाता हूँ intuitive understanding of what happens when you rotate something. So I have this weight that I've tied with the thread, and now I am rotating this. So when I'm rotating this, I'm trying to feel the force on my finger. I see that the force on my finger is radial. It's not tangential. वो radial है. तो I'll recommend that आप भी एक पत्थर को रस्सी पे बांध के and you try to see how you feel the acceleration and the force. So I'll try to draw a picture that is as perfect a circle as I can. So this is, you can imagine, this is a circle. इस सर्कल का रेडियस r है and there is an object tied to the rope and the object is moving with uniform speed. V. And as you see कि ऑब्जेक्ट इधर मूव कर रहा है लेकिन एक्सेलरेशन इज रेडियल. द फोर्स इज रेडियल टुवर्ड्स दिस एंड यही लोगों को समझने में काफ़ी दिक्कत होती है कि जब मोशन टेंजेंशियल है तो फोर्स रेडियल कैसे हो. हम लोगों को अभी तक मोस्ट ऑफ द एग्जाम्पल्स वी हैव सीन कि अगर कोई व्हीकल है ऐसे और इधर मूव कर रहा है एंड आप इसको फोर्स लगाएं तो एक्सेलरेशन भी इधर ही होगा. यहाँ के केस में एक्सेलरेशन इज परपेंडिकुलर टू द मोशन ऑफ द ऑब्जेक्ट. So that's the non-intuitive part. So before we go into detail, I want to go over the prerequisites without which you will not understand. Prerequisites. Prerequisite. Number 1, Newton's first law of motion, and it's about inertia. So what that law tells you कि this object would have liked to go on in a straight line unless there is a force to not do so. तो इसको अगर मैं मैग्नीफाई करूं तो ऑब्जेक्ट जो है would have liked to go in a straight line but there is something that keeps going it in a circle. and यहाँ पे फिर आपको लगता है इस इंट्यूटिव कि फोर्स शायद टुवर्ड्स द सेंटर हो. दूसरा है न्यूटन्स सेकेंड लॉ ऑफ मोशन, which is force mass multiplied with acceleration, क्योंकि हम लोग फोर्स से डील कर रहे हैं. तीसरा प्रेरिक्विजिट जो है जो काफ़ी इन्वॉल्व है और आपको एकदम अच्छे से याद होना चाहिए, दैट इज वेक्टर एडिशन एंड सब्सट्रैक्शन. तो यहाँ पे आई एम गिविंग यू अ वेरी हाई लेवल रिव्यू ऑफ द मटेरियल if you are if it's not enough, I recommend that you pause this video, go study vector addition and subtraction and come back. तो एडिशन क्या होता है कि if there are two vectors a and b and we have a resultant called c, a plus b, so we can use parallelogram method, and this is C. This is also called tail to tail method. Okay. Now इसको देखिए हम लोग कैसे subtraction में बदल सकते हैं. Suppose you have to find this instead. So this is, if we rewrite as plus, so minus b के लिए what we have to do, let me use a different color. So this minus b has same magnitude as b, लेकिन डायरेक्शन एग्जैक्टली उल्टा है. तो अब जो है we complete this parallelogram and this becomes C now. So this is how this we will use a lot. चौथा, fourth prerequisite, it relates to triangles. So if there are two triangles which are similar का definition है theta और एक दूसरा एंगल फाई, अगर सेम है तो तीसरा तो ऑटोमेटिकली सेम हो जाएगा. सो इफ सपोज दिस इज R1, दिस इज R2, दिस इज V1, दिस इज V2, and if this is delta R and this is delta V, so by the rule of similar triangle, delta R divided by delta R2, and mind you these are all magnitudes, will be equal to delta V divided by delta V1. So this is a law of behavior of similar triangles. Now पांचवा है concept, the concept of free vectors. Free vectors का क्या है concept? कि if there's a vector in the space somewhere, V2, और हम इसको स्पेस के थ्रू मूव करें. Okay. As long as we are keeping the magnitude and the direction, this vector and this vector are the same. तो अब इस 5 prerequisites के साथ में now let's look at the problem of acceleration in uniform circular motion. So let me draw the picture of the circle again, and let's take two vectors two radius vectors, r1 and r2. So as I have mentioned before, दोनों वेक्टर का मैग्नीट्यूड is same is r, but these two are line vectors, और ये पॉइंट A है और ये पॉइंट B है, and this is theta. तो जो ऑब्जेक्ट मूव कर रहा था, if we want to find out the delta r, which is a vector, will be delta r2 minus delta r1. अब इसको हम लोग कैसे निकालेंगे? Using the method that we saw here. So what we will do, we'll draw a vector of the same magnitude but in the opposite direction, or is tail to tail. So let's complete. Let me use the yellow color. So we complete the parallelogram, and this becomes delta r2 plus minus delta r1. Okay. And as I just showed you, for free vectors, this is our delta r. We are free to move it to bring it to between these two. So if this is O, we have a triangle OAB, and this triangle's side OA is magnitude of R, OB, R1. We are talking about magnitudes, R2, and AB is magnitude of delta R. अब let's look at the vector. So इस point पे this is the tangential velocity, and इस point पे we have v2, and because it is uniform motion, circular motion, so the magnitude of is equal to v. Magnitude same hai, but they are different vectors. Now we have to find out delta v, which is v2 minus v1. So now again take my color blue for minus. So for minus v2 minus v1, this is minus v1. इसका क्या है कि मैग्नीट्यूड सेम है एज v1 और डायरेक्शन उल्टा है. Now we move v2 here, and this is, let me use yellow. And मैंने बताया कि फ्लेक्सिबल वेक्टर है, तो आप अगर डायरेक्शन और सेम रखें तो so it's the same vector. So now we complete this parallelogram, and this is your delta V. So we found delta V here. So up, let me bring those. This is V2 and this is minus V1 and this is delta V. So this is same as V1 of the parallelogram. So by the, because this is 90 degree, this is 90 degree, this angle is also theta the way it is here. So here we have two triangles, R2 so this is delta R and this angle is theta, and another triangle we have is, so this is V2 and this is minus V1 and this angle is also theta. You need to think about it, and this is your delta V. So by the law of similar triangle, we know that we can write delta R का magnitude divided by is same as magnitude of delta V divided by V1. तो यहाँ पे आपको सोचना पड़ेगा कि V का V1 और V2 का डिफरेंस और डेल्टा V कैसे दोनों सेम है. तो यू गेट दैट. तो नाउ यू नो कि डेल्टा R का मैग्नीट्यूड इज सेम एज R, क्योंकि रेडियस का वैल्यू R है, एंड डेल्टा V, now this is no longer a vector, this is the speed. तो अब जो है टाइम लगाते हैं हम लोग यहाँ पे. तो वेलोसिटी will be delta R and this is not velocity, this is average velocity. Okay? तो अब यहाँ पे अगर हम लगाते हैं इस इक्वेशन में ये वाला, तो what we have here, the delta R is delta V, and mind you this is magnitude. So we divide both sides by t, so delta R divided by t, यहाँ पे R हो जाएगा, is delta V एंड यहाँ पे हम t लगा देंगे. So now you see here that we have delta R का magnitude divided by t is equal to delta V divided by t, and you have here R divided by V. तो ये जो टाइम t है, this is your acceleration. So this is a average acceleration is R divided by V, और ये जो साइड है, this is your average V. So in other words, a average is equal to v square divided by r, and force is mass multiplied with acceleration. So here it becomes by r. So what we have seen so far, by doing this vector subtraction for the radial vector and the tangential vector, we have been able to come to this equation from the expression from the similar triangle, and then by adding this time we can find the average velocity, and on this hand you got average velocity and here you got average acceleration, and that becomes v square divided by r. So you will have to see this video multiple times, and the prerequisites are very important, because the law of similar triangle is what gives you this expression at the end. All right, so I look forward to your questions. Thank you. Bye.